and the important stakeholder to provide the water and sanitation services. So that's why it's nice. Then we can have also this WOP session here, which is about cooperation between utilities. And I'm very happy also that Hamburg Wasser is a knowledge partner of Aqua here, and we look forward to the session. We have here one honored guest who's not on the announcement, which is from GIZ, who are one of the funder of WOPs in Germany. And so we will have a small welcome by the utility platform, by Maria König. So maybe you introduce yourself.
Okay, good morning everyone. My name is Maria König and I come from Germany as well as Claudia, but from Berlin, and represent the utility platform program, the German utility platform. And that's a program funded by our Ministry for Development Cooperation, Economic Cooperation and Development. And it's a global program, the utility platform, that aims to mobilize, to partner utilities, German and international, for capacity development for these partnerships that you will hear about in just a minute. And what's the essence, or what's the intention, as we also heard in the previous session already and got a glimpse of these partnerships. So that's all about peer support, peer learning. It's the engineers, it's the technical staff, but also on a management level, at ICE level, the colleagues meeting, exchanging, learning together, and you will experience what that means in detail in a second. And they aim for a longer-term partnership, so that means it's also institutions partnering. There is in that case the whole Hamburg Wasser behind, and there is lots of resources, lots of expertise to deploy, and there is hopefully Miahuna at large also engaged, and in this case, and engaging in this partnership. And last but not least, so this is just one element, also looking at it from the perspective of German Development Cooperation in Jordan in this example. So that's, as we believe and hope, it's complementing other initiatives. So of course capacity development without access to some funding, or without longer term or broader aims for institutional capacity development, that will maybe not have the effect. But if that can be combined well, then we hope that the partnerships at eye level, expert partnerships, can have a benefit. And that's why also I would like to ask Dirk, my colleague from GIZ Jordan, maybe quickly to say a word how he sees it fits to the to the portfolio of the German Development Cooperation. Quickly, maybe. Thank you.
Yeah, hello, good morning. I'm Dirk Winkler. I'm from GIZ. I'm the project manager of the project Wastewater Treatment, Reuse and Water Supply. And we are basically supporting water utilities in Jordan. All of those three water utilities, Yarmouk Water Company, Miahuna, and Aqaba Water Company, and capacity development. And there are so many activities, including infrastructure master planning, hydraulic modeling, supporting the water training center in Marka, for example, with organizational development and rehabilitation. Yeah, and we are in close cooperation with Hamburg Wasser with this utility partnership to coordinate and to complement our activities.
Thank you. Yeah. Thank you very much for the introduction, Maria and Dirk. And before we come to the very interesting 4 presentations that we have today for introducing WOPs, telling some stories from the WOPs, some results, all about drinking water, while we had the other WOP session on sanitation and wastewater in the morning. I just want to know, because I think the people here who are the presenters are also wondering who's sitting in this room. So I want to ask you, maybe just by raising hand, a few questions. So first question, from which country are you coming? So who's coming from Jordan? Okay. The majority, I guess, when I see, is coming from Jordan. Who's coming from any other Arabic countries? Okay, from which countries? Iraq? Lebanon? Lebanon as well, okay. Nice to see you here. And who's coming from other countries, like me? Okay, okay. So we have now, okay, an idea about the countries. Who's coming from a utility? From a water utility? Usually public utility, I guess, right? Okay, utility. Private sector, private utility? Okay, few. So who else do we have here? UN? Else? We have donors? GIZ? Okay. Regulator, okay. Regulator, government, okay. So we have a good idea who's in the room. And the question, my final question is, have you ever heard about water operators partnerships? Yes, you have. Yes, if you raise. Who has never heard about water operators partnerships? Who has no idea about it? Nobody. Okay, so that's for you. You can be then a little bit quick when it comes to explaining the general background, maybe, so we can go more into detail. So now we know a little bit better. I will introduce each of the presenter one by one. So we come to the first presentation, which is on our partnership, which we have between Hamburg Wasser and Miyahuna. And yeah, maybe the question was also in the former session, why is Hamburg Wasser, like a German utility, active in water operators partnerships? And for us, we have since a few years, we have an international strategy within also our company, which is a German utility, but we really are committed also to share our knowledge to other international utilities. Because we believe we can share our knowledge and at the same time we can learn from others. So especially we can learn also from other utilities in terms of climate change, droughts, but also digitalization are big issues where we also see that other utilities might be better than we, and we want also to learn from them. And as I said earlier, also our owner, who is the city of Hamburg, is really asking us also to contribute to the Agenda 2030, especially to the SDG 6 and 17, and also a number of other SDGs. Okay, now I come to the first presentation. I introduce the partnership, and you will go a lot more into details of this partnership. We have Engineer Malak, who is sitting there. So I have to do both here. No, this is not the one. This is the one, right? Yeah. Engineer Malak is working for Miyahuna and is head of is a manager of the monitoring performance unit. Her background is in robotics and mechatronics, and she likes very much IT and also robotics, as she said, but she also likes very much reading. And she will do the presentation together with my colleague Karam from Hamburg Wasser, and he's originally from Syria. He did environmental engineering in France, and he speaks 4 languages fluently. So, and I'm coordinating and managing the WAP projects together with him at Hamburg Wasser. So, please, come here.
Assalamu alaikum. Today we will speak in English because of our colleagues from Germany, even it's an Arab Water Week. Today we will be presenting the water operator partnership, and I'm always enthusiastic about this partnership, and maybe Claudia noticed that during the conference that I just keep talking about the partnership, because like I felt a partnership between a utility and utility is a way better than having a consultant where you need to elaborate the situation and then discuss like the points with them and then having a final report. But the way here is different, that we just like start with the topic and like we have the same challenges, we know the concept, so it's like easy to go directly to the topic. And like we're making good results. My colleague will show you how we proceed with this partnership and we reach to points that is beneficial for Mia Huna and as well for Hamburg. I'll be presenting, as Claudia said, with Karam from Hamburg Wasser. And throughout this presentation, we're going to do introduction about the partner utilities. And we're 3 utilities in this partnership. And like we just to talk about key figures in a nutshell. Also, we'll talk about the concept of water operator partnership and what is the advantages of peer learning approach. And like since I've been within this partnership, I could elaborate the concept. And what is the activities in this partnership between Mia Huna and Hamburg Wasser and Hansi Wasser, as well what is the field of collaboration. Let's start with Mia Huna. I'm so proud to be part of Mia Huna because we're the largest utility in Jordan, and like we're covering 4 governorates and we're serving around 7 million population with 1 million meter, which is a customer, and like we're managing water and wastewater in Amman, Madaba, Zarqa, and Balqa.
Thank you, Malak. Please allow me to say a few thanking words in Arabic. So مثل ما قالت زميلتي اسمي كرم خضري. من الأصل أنا من حلب من سوريا. إلي أكثر من حوالي 10 سنين بألمانيا وبسعدني كثير بيشرفني كثير كون هون معكم. كل الشكر لأكوا للتنظيم والدعوة، الشكر للسادة الحضور لجيدكم واهتمامكم، والشكر الخاص كمان للمترجمين اللي عم يعملوا شغل كتير بروفيشنال. شكرا كتير. So without a further ado, I would like to say a few words about the other 2 partner utilities, one of which I come from, Hamburg Water. So Hamburg Water is the largest water utility in northern Germany. A lot of things that I was supposed to say have already been said. Thank you, Claudia. And Hamburg Water is 100% public-owned utility, so it's owned by the city of Hamburg, and it operates and provides high-quality drinking water for about 2.2 million people in the metropolitan region of Hamburg, and the water comes exclusively from groundwater sources. Hamburg Water operates as well a central wastewater treatment plant that can take up to 19 cubic meters per second on a rainy day and treats around 400,000 cubic meters of wastewater per day. And as well, it operates a water and wastewater network with a length of around 12,000 kilometers, enough to reach the city of Buenos Aires, starting from Hamburg. The second or the third partner in this case within our WOP is the company Hansi Wasser from the city of Bremen, which has a public-private partnership agreement with the city of Bremen and other private partners to operate a combined and separated sewer system with a length of around 2,300 kilometers and has 2 wastewater treatment plants, Seehausen and Fage. My colleague Idris presented them shortly, with a capacity of 1,160,000 PE respectively. Hansi Wasser treats as well the generated sludge via anaerobic digestion to produce biogas and generate energy and heat from which via CHP units. So, in a nutshell, what are WOPs? Most of that has already been said. So, a WOP relies mainly on trust among partners to tackle challenges who work on equal ground with each other by sharing the knowledge and expertise to improve the performance of the water utilities in order to achieve better and more sustainable services for their customers via a peer-to-peer dynamic and on a no-profit basis. So German WOPs are financed by the Federal Ministry, so by the German Federal Ministry for Economic Cooperation and Development, and implemented by the GIZ in cooperation with other German entities such as German Water Partnership, the Association of Public Utilities, and Engagement Global. I will hand over now to my colleague Malak. Please.
We will talk about the Sustainable Development Goal. As we are all utilities, we're sharing the same vision toward achieving the goal of ensuring availability and sustainability management of water and sanitation for all. Like, as we know, every city have many problems regarding to have deliver the water to the customer in better services. And in Jordan, as we're coming from a background that we supplying water in intermittent supply and we have limited resources, we want to make sure that this partnership will lead us to achieving the Sustainable Development Goal. So why the partnership is so important, and why is the peer learning is important? Like, we're working in a teamwork, and like you will see that there is from Hamburg who are working on the water quality, and our colleagues from Yahuna who's working in water quality will work as a team. And the teamwork here fostered the collaboration, the patience, and we'll discuss many things among the challenges that faces Yahuna, and like they recommend solutions and we apply it. Engineer Idris was presenting in the morning as well the partnership between Yahuna and Hazi Wasser regarding the wastewater. So we're working as a team, and like during the activities we will show you how this approach is working. And the feedback is better. I'm going to the point that since we're utilities, we have the same challenges, we're speaking the same language. So it's not a relation between a utility and a consultant, it is from a utility to utility. So even Hamburg, like they discuss things that are not there in Hamburg, and the same things, because as Claudia said, she wants like to know about digitalization. Maybe here in Jordan we have different projects, and this is a two-way communication where we have a better feedback. And also it supports diversity. Like we're all going toward achieving the goal. Even we're coming from Germany, Jordan, and Syria, we're working together toward better services for the customer, as it is our mission, like to have better services for the customers.
So before diving into the technical fields of cooperation, let me please give you a glance into the WOP activities that we are undertaking together. So we started in the year 2021, mid in the COVID crisis, so technical exchange meetings were conducted online and on a regular basis to discuss the challenges that each utility has, mainly to get to know each other at the first place, gather some data and develop some measures to tackle the challenges faced in a jointly manner. So as you can see, here are the two groups of drinking water to the upper left and wastewater to the down right. Furthermore, once travel restrictions were lifted, on-site missions were conducted and took place in Jordan to visit the partners, to meet them actually on site and conduct further discussions and technical exchange, also to experiment on sites and come up with a solution, as I said, in a jointly manner. In addition to this, these missions further exchange events with other WOPs, other German and other financed WOPs were conducted as well with other partners in Germany. So we were invited to the city of Stuttgart to share the WOP activities, WOP experiences, and the elaborated solutions among each other, so to benefit from each other, so to say, followed by a visit to the IFAD 22 exhibition in Munich, where the peers had the chance to meet relevant suppliers on site, discuss directly with them, and explore maybe further possibilities into technical solutions and equipment. This visit had combined many activities, so one of which included also excursions to technical facilities in Germany, where the partners had also important and direct insights into the operating procedures of German utilities and water companies. As you can see in the pic,
Quickly.
the peers were preparing to enter a drinking water reservoirs in the city of Stuttgart, so fully equipped to ensure the safety and the delicacy of the process on site. Another activity within the WOP is called job shadowing. So basically it's a training on the job on site in Germany. So training offers were organized at Hamburg Water and Hanse Water respectively, for our peers to learn directly on the job, have also the opportunity to discuss with the peers, with the technicians on site, exchange on their manners, on their problems, and come up with solutions, widen the horizon, and so on and so on. And now I will hand over to my colleague Malak to tell you more about the fields of cooperation that we are undertaking together. Thank you.
I will not take so much time, but I'll go to the topics and work packages quickly because my colleagues will present every work package in detail. We're working on 3 work packages. The first one is the water production, and Engineer Ghassan will present the results that we have achieved. And we also have a water quality and key performance indicator. Our colleagues from Hamburg will join us this week to the labs at Mia Huna, and they're working on different topics. As well, for the KPIs of being the job shadowing, we've discussed a lot of topics regarding enhancing the performance of the utility. And as for the wastewater management, Engineer Idris was presenting the partnership in details in the first sessions at morning. So for optimization of drinking water production, we have did an optimization of fluctuation and optimization of filtration. And for the water quality, the topics are in progress to be discussed, but it's mainly things related to the key performance indicators in labs and other topics related to the water quality. As well, we discussed the digital transformation and the management of the well fields. For wastewater and sludge management, it has been presented in detail in the morning, but it's mainly the optimization of energy in the wastewater treatment plants.
So just like my colleague Claudia said, we have also further international activities within Hamburg Water. So if you are interested, please follow us on LinkedIn, where we post regularly on our missions and our progress. We have also some video nuggets indicating the results of the cooperation. So you have the link. Please feel free to follow us, and we will be happy to get in touch with you. So thank you very much for your attention.
Thank you very much. So if you have very short questions, you can ask now, but we hope we have later some time for discussion. The next presenter is about the first work package we were starting to work on, which is on water production. Dr. Christoph Schekala is with Hamburg Wasser. And he has already almost 40 years of experience. And basically, his topic is water production. His background is biotechnology by professional background, and he has also more than 25 years of international experiences in a number of countries. So I think, I don't know in how many countries you were already, Christoph, so I think it's more than 10 countries probably where he tried to share his know-how on optimizing the water production. And he will summarize a little bit about it in the next presentation. And for when he's not working, he is a musician.
Thanks for this nice introduction, Claudia. Salam alaikum. First, I would like to thank Aqua for the invitation and for the wonderful chance to present our WAPs here on the Arab Water Week. This is a great honor for me to have the chance here. And thanks also to Malak and Karam for the good overview what the WAPs are doing. In my presentation, I want to go into more detail what we are doing in the focus area of water treatment. And this is pretty important for all utilities because to produce a really good and safe drinking water quality can be quite challenging. And it is very costly because to bind all the turbidity from the surface water, from the resource, you have to add high purity, costly chemicals. The consumption is high, and this is, of course, costly, and it's really worth looking at, beside other things I come to later in more detail. First, I will introduce the other partner utilities, and then I will explain to you our approach, how we look at a water treatment process, what are typical issues to address, and what can be achieved by optimization. Finally, trainings follow up. How do we secure that our optimization activities will be sustainable solutions, lasting solutions? This, we have some accompanying measures to ensure this. But first, the partner utilities. Hamburg Wasser has 5 partnerships at the moment, water operator partnerships. And because water treatment is so important, we have in 4 of these partnerships water treatment as a special focus area. This is, of course, Miyahuna. And I will not go into detail about the results with Miyahuna, because in the next presentations, this will be done by Ghassan Al-Sahi. We have 2 water operator partnerships in northern Tanzania, both taking water from Lake Victoria. Also quite challenging water quality. This is Kashwasa and Mawasa. Kashwasa is located in Shinyanga, and Kashwasa and Mawasa at Mwanza, just by Lake Victoria. And another partnership is with Kiev in the Ukraine. Of course, due to the war, we cannot travel there, but we try to support as good as we can, mainly by online meetings. So these are our partners we're working on in the field of water production. Now, not moving. I try it this way. Not moving too. Will nicht.
Der hat Low Battery schon vorhin angezeigt.
Aha.
Den hier unten.
Den unten, okay. So, these were the partners, water treatment optimization approach. Yeah, low battery, so yeah. So this is the overview over the normal water treatment process treating surface water. The raw water can come from different sources. It can be rivers, lakes, dams, whatsoever. All this raw water has the same challenge: turbidity, contaminations. We have to add chemicals. Normally, the first step is pre-chlorination to control biological contaminations. A lot of other chemicals have to be added, mainly flocculation chemicals, to bind all these turbidity, to get it into flocks that you can remove from the water. This flocculation is done in the flocculation unit. The next step is sedimentation. Before we have final disinfection, the polishing is the filtration process. So most of the turbidity is removed by flocculation, sedimentation. Filtration is then removing residual turbidity to have a really good, clear water. The recommended target is 1 NTU, 1 turbidity unit. This is really very good, clear water, and this is necessary for proper disinfection. We can look at pre-chlorination. Is it really necessary? All chlorine used in the process that is not really necessary should be saved. It's a toxic chemical and a costly chemical. Then a really big bullet point for us are the chemicals. In many treatment plants, we find that chemicals are the main cost factor in the production process. So it's really worth looking at it, and we have good experience what types of chemicals, what chemical combinations can be used, how to do it properly. And optimization of filters is important, very important too. The sand bed, the filter bed, can that be optimized? Filter backwash is the big thing, because every cubic meter you don't have to waste for filter backwash is additional production. So, and in some cases, it is also worth looking at post-chlorination, not so much to look whether it is necessary. Of course, it is definitely necessary to have safe drinking water, but what source of chlorine are you using? Using chlorine gas, calcium hypochlorite, a solid product. What I've been introducing in several countries is to use electrolyzers. Electrolyzers are producing chlorination solution from table salt solution. With installations, easy installations you have directly in the treatment plant. And for example, in our water operator partnerships with Tanzania, they have at the moment the problem, the access to chlorine gas. So we will go to electrolyzers to produce disinfection solution on site in the treatment plant. They're independent. Table salt is not toxic. And the whole chlorination is much cheaper than to use chlorine gas. So this is also worth looking at. We go through the different steps and the different opportunities. We start with pre-chlorination. We start with the beginning of the process. Of course, there it is very important to look, is it really necessary? In some countries, it is required by law to have pre-chlorination. Normally it is not. And if you don't have a really highly contaminated raw water, it is worth questioning if pre-chlorination is necessary. For example, in Tanzania, we found the source, the Lake Victoria water, is not highly contaminated. And in many cases, pre-chlorination is consuming more chlorine than post-chlorination. So we stop pre-chlorination. A huge saving and still wonderful drinking water quality. No high fecal contamination, no high numbers of algae, no need to reduce color, no need for pre-chlorination. We just stop it and save more than 50% of chlorine costs immediately. This is really quick win in the water treatment plant. Even in the first, the so-called fact-finding mission, we could stop and from this moment save 50% of chlorine cost, as really substantial saving. As I already explained, flocculation chemicals. The maybe most important point to save, what can we do? We normally start with laboratory tests. Laboratory tests to investigate different types of coagulants. Coagulants are the chemical substances forming a floc in which all the turbidity is bound to get clear water. We have different choice of coagulants and also other chemicals supporting the formation of really good flocks, organic polymers. So what combination is working well, most efficiently? We first test in the laboratory with the so-called jar test. I'll show you the pictures on the next slide. Of course, it must be ensured that we're using chemicals or changed chemicals. They must have the purity to be used in drinking water treatment. Sometimes I see treatment plants using cheap chemicals for industrial purposes. I cannot recommend this because this will remove turbidity, but it will contaminate the drinking water. So all the chemicals must have potable water grade, PWG, potable water grade, purity for drinking water production. And when the laboratory tests have been completed successfully, of course, we want to apply this in the large-scale process. And this requires some adaptations and maybe some additional tests to identify the ideal dosing points in the process and the right energy input for the mixing that the chemicals can work properly. And when this is done, the maximum we have reached was in the plains in Tanzania, more than 50% saving of chemicals. And this means a huge saving also in production costs. So this is a big thing. With a good exchange of experience, you can get very, very far. And this all follows our general motto, make more and better water for less money. So here's some pictures. We start with the laboratory tests. Battery is low with this. So on the left picture, laboratory tests. The jar test, you stir, you add the chemicals, you look how the flocks are, let them sediment, how clear is the water. The middle picture shows you perfect flocks, big, dense flocks. The water above is clear. That's what we want to have. And finally, you see Ghassan, the next speaker, pointing to the new dosing point because we have changed the dosing points to really save, but this is part of the next presentation. Bin gleich durch. So, post-chlorination, filtration. We first inspect the filter bed. We often find that there is a very fine material lying on the sand bed, and this is blocking the filters. They have to be backwashed very frequently. This must be removed by hand. And of course, the filter backwash, if you optimize the filter backwash, a lot of water can be saved. For example, what we have achieved is 30% saving in backwash water use, meaning 15% higher production, because this water is no more necessary for filter backwash. A few pictures. The left pictures, it is very easy to check. You just remove the very surface of the sand bed and check, is this very fine material? If it is very fine material, remove it. Otherwise, you will get an inefficient filtration process with frequent backwashing. This is a normal material with the photo below. So it is very easy to see, is there undergrain, is there fine material lying on the top? Remove it. In the middle, the top picture, this you have to remove by hand. But you do this once, and then the filters are safe. Sometimes you can even find you have a mixture of different materials in the filter, then maybe it is necessary to exchange the filter material. And filter backwash, this is the bottom picture in the middle, extremely important to look at the method of backwashing and see how to optimize, and can also lead to huge savings. Finally, post-chlorination. I already explained electrolyzers producing chlorination solution from table salt using electric energy. And on the picture there, the lower tube, this is the electrolyzer cell in which the table salt solution is converted to chlorination solution. It requires energy, but not very much. And then you have chlorination solution produced exactly to demand at lower cost, also a very interesting alternative. So this was a short overview going step by step through the different stages of the water treatment process to identify potential for optimization. In the discussion with the partner, we discuss, we define, and we follow the optimization activities. This is already one part of the training, of the exchange of experience. We offer additional trainings to offer more background, scientific, technical background. And of course, the job shadowing gives additional exchange between the experts at Hamburg. Follow up, we have an action plan, and we use performance indicators to clearly monitor our progress and to plan the future progress. And all these results go into the utility platform so that other partnerships can also benefit from the results we obtain together. This is a short overview what we are doing in the field of water treatment. And because my time is over, I guess can just very briefly say thank you to a huge number of people I cannot name personally. So I put the group photos. This is Miyahuna team, and we have the Kashwasa team from Tanzania, and also my colleagues like Lydia and Dorothea, very much involved in this partnership. Thanks all to you all for the wonderful cooperation, and to the audience for the attention. Thank you very much. Shukran.
So, any very quick questions then now? Otherwise, you need now your translator if you don't speak Arabic. Because we have now the next presentation, which is the perfect follow-up. Because it's also about water production. But in detail, what we do is this one, right? Yes, it's this one, right? Yeah. What we did at the, I don't know what's going on here, meet now, no. And this one, learn more, no. This one? This one. I tried already, but I just want to. Yeah, you mean, okay. Yeah.
This, right?
Yes. But I cannot remove this one. Do you know how to remove it?
I wish.
Yeah, but I think it's
it
coming
wants-
now.
it
Yeah,
wants
it's
to
coming now. Yeah. Thank you. So, Ghassan, Engineer Ghassan is since 20 years already with Miyahuna, and he is his background is chemical engineering, and he's now head of operations. And you are already wondering what is his hobby. So he said he likes very much to fix all things in his house. He has a house with 5 children, I think. So he's always the one who takes care at home of everything. So please, Ghassan, floor is yours.
السلام عليكم ورحمة الله. الله يعطيكم العافية جميعا. نشكركم على الحضور ونشكر أكوا على الاستضافة، ونتمنى لكم إن شاء الله وقت يعني طيب. نتمنى وقت طيب للجميع إن شاء الله مع هاي البرزنتيشنز اللي بتتكلم عن قصة نجاح في محطة زي. طبعا يعني العمل بدأ العمل في مش موضوع الشراكة في العام 2021، والثمار جنيناها في العام 2022، والآن إن شاء الله راح نبلش نحكي عن التجربة اللي مرينا فيها خلال هذه الفترة. طيب حركش كلاوديا. كما أسلف الزملاء يعني في حديثنا عن موضوع الووتر باكيجز، كان الموضوع بيشمل الووتر برودكشن والويست ووتر اند سلادج مانجمنت والووتر كواليتي. احنا حديثنا اليوم راح يكون عن الووتر برودكشن. طبعا احنا بالدرينكينج ووتر اوبتمايزيشن كان الكلام عن 3 مواضيع. الموضوع الاول كان الاوبتمايزيشن اوف فلوكيوليشن اند كوجوليشنز، والموضوع الثاني كان عن اوبتمايزيشن اوف فلتريشن سيستم، والموضوع الثالث كان عن اوبتمايزيشن اوف ديسانفكشن الدير علة. هذول المواضيع الثلاثه اللي احنا اشتغلنا عليهم مع شركائنا في محطه زي. بحب اقدم اول شيء عن محطه زي. كما تعلمون هي محطه انشئت في العام 1985. كانت القدره التصميميه لها، القدره الانتاجيه 45 مليون متر مكعب في السنه. تم عمل توسعة لهذه المحطة في العام 2001 حتى أصبحت 90 مليون متر مكعب في السنة. طبعا الآن محطة زي حتى الآن ما زالت تعمل بقدرة عالية جدا، قدرتها التصميمية. ما زلنا يعني مستمرين بالعمل، وبنزود العاصمة عمان ومحافظة البلقاء في المياه اللازمة للشرب، تقريبا 38% للعاصمة عمان و60% لمحافظة البلقاء. بحب أعطي فكرة بس عن الرو ووتر ريسورسز. بالنسبة لنا إحنا يعني هي أغلبها مياه سطحية عابرة للحدود. يعني في جزء من هاي المياه يأتي من نهر اليرموك اللي هو بين الحدود الأردنية والحدود السورية، وكذلك الحال بالنسبة لسد الوحدة. كما تعلمون هو سد يعني تغذيه 4 أودية. وادي في الأردن هو وادي الشلالة، وادي زيزون يعتبر وادي حدودي، وكذلك الحال في عندنا واديين في الأراضي السورية اللي هو وادي الحرير ووادي علان. هاي أودية كلها يعني من الجانب السوري بتغذي سد الوحدة، ويعتبر يعني من السدود الرئيسية اللي بتغذي محطة زي. ايضا المخيبه ويلز كذلك الحال، يعني هاي برضه في ابار المخيبه مياه جوفيه بتختلط في قناه الملك عبد الله حتى توصل، بتمشي مسافه 65 كيلومتر حتى توصل منطقه دير علة. بتم في منطقه دير علة المعالجه الاوليه اللي راح نحكي عنها بالكلورين دايوكسيد او بيرمنجانات البوتاسيوم. بعد ذلك بيتم رفع المياه من خلال 4 محطات رفع الى محطه زي. بيتم في محطة زي اللي هي المعالجة الانتنسيف تريتمنت لتخفيض العكارة وللتعقيم. بتبدأ المعالجة في محطة زي ما احنا شايفين بالبروسيس فلو تشارت. بتبلش في إضافة الباودر اكتيفيتد كربون لإزالة الطعم واللون والرائحة للمياه. بعد ذلك بيتم عمليات الكوagulation والفلوكيوليشن اللي هاي الشغله الرئيسيه اللي راح نتكلم عنها اليوم، اللي كنا احنا نستخدم ماده الفريك سلفيت، والان نستخدم ماده الفريك كلورايد وماده الكاتيونيك بوليمر في عمليه الفلوكيوليشنز. باختصار يعني عمليات المعالجه اللي بتتم في محطه زي هي عمليات بري تريتمنت، فيزيكال ستيجز اند كيميكال ستيجز. احنا بلشنا نشتغل على موضوع الاوبتمايزيشن اوف زي درينكينج ووتر تريتمنت بلانت، وبلشنا نشتغل على موضوع اللي هو الفريك كلورايد، لانه نسبه استخدام الفريك كلورايد او الكوست الكيميكال كوست تقريبا يعني 27% فريك كلورايد من مجموع الكوست الكيميكالز. احنا طبعا في السنه 2 مليون و200 ألف دينار هاي كيميكال كوست بتكلفنا عمليات المعالجة في محطة زي. والكوست اوف كواجولانتس بتكون 590 ألف دينار، يعني مبلغ عالي جدا بيسوى أن نشتغل عليه حتى يعني نخفضه. اوكي. كما تحدث زميلنا كريستوف عن موضوع التربيديتي، كيف يتم التخلص منها بإضافة الفريك كلورايد أو الكاتيونيك بوليمر. راح أتكلم باختصار عن الميكانيزم. زي ما احنا شايفين إنه بتكون البارتيكلز الموجودة في المياه تكون تحمل شحنة سالبة. بيتم إضافة المواد اللي هي المجمعة اللي هي الكواجولانتس، فريك كلورايد أو الفريك سلفيت اللي بتحمل الشحنات الموجبة، وبعد الإضافة بتكون الفلوك هذا اللي بيتكون بتكون هاي عملية كأوجوليشنز. بنضيف بعد ذلك مادة الكاتيونيك بوليمر. الكاتيونيك بوليمر بتعمل تخثير وتجميع لهاي الفلوكس، بيزداد وزنها وتترسب، بصير عملية الترسيب لها أفضل في الستلينج بيزن. طبعا احنا بدأنا العمل من خلال يعني عملنا بروح الفريق مع بعض. بدأنا من المختبر، من الجار تيست، عملنا بعض التجارب، كانت يعني في يعني توصيات لمحطة زي انه لازم نزيد الزمن بين إضافة مادة الكاتيونيك بوليمر ومادة الفريك كلورايد. احنا كان عندنا اعتبارات تصميميه يعني في المحطه بتعرف من 85، وكان في يعني بعض الشغلات كانت حاله دون انه احنا يعني نباعد بين هاي الاضافات، فكان يعني الزمن اللي كنا نضيف البوليمر بعد الفريك كلورايد كان زمن قليل جدا. كانت التوصيه ان احنا نضيف بعد 30 ثانيه، نضيف ماده البوليمر بعد 30 ثانية، وأخذنا قرار بهذا الموضوع وبلشنا نشتغل على الموضوع في محطة زي. عملنا بعض الشغلات التعديلات التصميمية في المحطة، ونجحنا بفضل الله عز وجل وبهمة يعني المتعاونين، ونزلنا من الكوست ومن الكونسامبشن للكيميكالز. يعني هنا بنشوف احنا فرضا الشارت هذا بوضح لنا، عملنا احنا تقييم وشفنا قديش الاستهلاك، وقارنا شهر بعد وشهر قبل عملية الإضافة، فلاحظنا إنه إحنا وفرنا تقريبا 100 طن بير مانث فريك كلورايد. يعني بتلاحظوا هنا فرضا على سبيل المثال الخط الأزرق هذا بيمثل الاستهلاك قبل تغيير نقطة الحقن وقبل التعديلات اللي سويناها. الخط الأصفر البرتقالي عفوا بيمثل التعديلات اللي صارت بعد عملية التغيير والتعديل، وهذا كله انعكس على الكوست. حتى احنا الآن تقريبا صار نسبة التوفير 24,000 دينار بالشهر، 24,000 دينار تقريبا في الشهر صار توفير من خلال هذا التعديل اللي تم. طبعا نسبة البرسنتج اوف سيفنج كوست 44% كما يعني خلال 7 شهور. هذا طبعا intermediate evaluation for ferric chloride. طبعا احنا هاي اللوحه تورجينا كيف كان الدوز، كان تقريبا يوصل ل 35 30 في اللي هو الخط الازرق مثلنا الدوز قبل عمليه التعديل. الخط البرتقالي بيمثل لنا الدوز بعد عمليه التعديل، كيف نزلنا تقريبا لل20 لل15. الان احنا ماشيين تقريبا بالدوز لل15. طبعا الخطوط في اسفل الشارت بتوضح لنا قديش التربيديتي في السيتلينج بيزن، حافظنا عليها كما هي. يعني احنا same turbidity result with low ferric chloride dose. الموضوع الثاني راح نتكلم عنه اللي هو optimization of filtration. طبعا احنا عندنا 12 rapid sand filters في محطة زي. هاي الفلاتر بتحتوي على مادة الجريفل 30 سنتي والساند 30 سنتي والانثراسايت 60 سنتي. طبعا احنا كان في يعني فكرة انه احنا نبلش نعمل بعض التعديلات التصميمية كذلك على موضوع هاي الطبقات. فوجدنا انه لانه العكارات في الاحواض الترسيب منخفضة على مدار الاعوام السابقة، وجدنا انه يعني في عندنا مجال انه احنا نزيد طبقة الساند ونقلل طبقة الانثراسايت. الانثراسايت نزلناها في فلترين خاضعات للتجربة والتقييم. حتى الآن نزلنا الأنثراسايت ل 50 سنتيمتر ورفعنا الساند ل 40 سنتيمتر. هذا التعديل تم على فلترين، فلتر في المحطة القديمة وفلتر في المحطة الجديدة، وما زالوا تحت التقييم والدراسة. طبعا احنا يعني من خلال يعني انه كل ما زدنا الطبقه الاقل مساميه في الفلتر كل ما زادت كفاءه عمليه الفلتره وكل ما حصلنا على مياه افضل للشرب. اخر شيء نتكلم عن موضوع الاوبتمايزيشن اوف كلورين دايوكسيد ديسانفكشن. الموضوع هذا كانت في فكره انه ندخل فحص تشغيلي جديد في محطه المأخذ في دير علة اللي هو فحص ORB Oxidation Reduction Potential. وكانت التوصية انه احنا يعني حتى نضبط قديش الكباسيتي لديسانفكشن فإنها تكون 700 ملي فولت حتى نشوف إحنا الجرعات إحنا بنشتغل فيها هل هي أعلى من المطلوب ولا أقل ولا يعني المطلوبة. فصرنا نعمل جار تيست جديد في مختبر دير علة ونفحص ال ORB على دوز في كيميكال كلورين ديوكسيد وحتى نتأكد إحنا إنه الجرعات هي الجرعات المناسبة الجرعات المطلوبة. وهي هنا التشارت بيوضح لنا إنه كيف إنه إحنا تقريبا قريبين جدا من 700. هذا يعني صار هنا أمور سهلة لعمليات التقييم. الآن إحنا يعني ما زلنا نعمل مع شركائنا وزملائنا وبكرة إن شاء الله عندنا كمان يعني جولة في محطة زي إن شاء الله وعندنا شغل متواصل ونتمنى أن نوصل لنتائج أكثر ونشكرهم على الجهود اللي بيبذلوها وإحنا بنعمل بروح الفريق ونتمنى التوفيق للجميع وبشكركم على حسن الاستماع وبارك الله فيكم.
Any very quick questions? Then, please, very quick, very short. While I'm...
Too many shorts. Mohammed Faris, desalination expert, Green Bath Solutions. في عندي in English engineer غسان. Reduction of ferric chloride by reducing the retention time between the ferric chloride and the cationic polymer. What about the cationic polymer? Did you get any reduction of consumption? Second thing, anthracite.
No. That goes too far now. So maybe a very short answer, and you can continue later on, yeah?
Okay.
Please. Short answer.
Regarding cationic polymer, still the same. Our dose now about 1 to 1.2 ppm. The last week, we see that we can reduce the cationic polymer, and we reduced it to 0.8. And we still monitoring these changes. Okay?
Thank you. So now we have the last presentation, which is by a guest who is not part of our WAP, but part of a WAP with World WaterNet. And I'm happy to introduce Tuka Kadi. And she is project coordinator of one of the Water Operators Partnership with Palestine. And she's part of the young expert program, but she has also quite some work experience with rehabilitation from networks. And she likes to read. So please. And the topic is another topic. So now we move from water production to non-revenue water to the beginning of the water supply. But I thought it's pretty interesting also for you. So please.
Good afternoon. I am Tuka Qadi. I am working with the Palestinian Water Authority as a project coordinator with World WaterNet company. Today I will speak these topics: overview of non-revenue water in the West Bank, partnership overview, non-revenue water assessment for North Hebron, and finally, Bitula area as pilot of a smart water solution to reduce the non-revenue water. The average percentage of non-revenue water in West Bank is ranging from 33% to 38%. And of course, Palestinian Water Authority have a strategy to reduce the non-revenue water. For example, awareness programs for citizens, inspection of violations on the water network, implement the standard specification for meters, capacity building, and cooperating and coordinating with donor. I would like to talk about the factor of high percentage of non-revenue water in West Bank. For example, old water network, illegal house connection, ancient water network, poor administrative, technical, and financial. Palestinian Water Authority keep updating national policy and the strategy of non-revenue water regularly. And Palestinian Water Authority aim to reduce non-revenue water to 28% by 2030. Palestinian Water Authority have partnership with World Water Net, which is a long-term water operators partnership, 2020 until 2030. World Water Net have two programs work on the West Bank. Waterworks focus on drinking water, Blue Deal focus on wastewater. And two programs aim to build capacity and exchange knowledge in the two areas in West Bank, Salfit and North Hebron. I would like to talk about we work on non-revenue water, reduction, GIS development, implementation of tariff bylaw, rainwater harvesting with waterworks. This is the map for the north of Hebron. And I would like to take North Hebron example of non-revenue water. We are dealing with Joint Service Council on this area. Since Joint Service Council established to provide service for more than 250,000 citizens living in 11 local authority, covering an area 500 kilometer. This area facing to high non-revenue water, as you see in this map. And I would like to mention how to calculate the non-revenue water in West Bank. We subtract between the quantity water from the sources and consumption for the household. We are not fully the water balance of non-revenue water. Partnership, World Water Net and Palestinian Water Authority, cooperating with Palestinian company to implement of smart water solutions. And we chose Bitula area. Why we chose Bitula area and our objective? Feature smart solution, our methodology, leak detection action plan, existing works and expected result, and finally, action of results. We chose the Bitula area because already have a high non-revenue water is 37%. Located in our project area in North Hebron, has financial and GIS informations, and the team in Batula motivated to work with us. And our objective to detect the active leakage and to take comprehensive platform for Bitula area. For more information about our smart solution, this is the features: remote monitoring, real-time data collection and analysis, automatic data analysis, accurate and precise leak detection, automatic reporting and alarms system, and system flexibility. Okay, how we start to work. I would like to about our methodology. We divided the Bitula area for the 4 zones based on the topography and field visit, and in addition, partner supervision. After we divided the Bitula area for the 4 zones, the Palestinian company installed mechanical meters and smart units for the start of the zone. Smart unit, which are data transmitter connected to meter and sensor to collect real-time data and enable real-time monitoring, and web platform, which is a software that provide a friendly user interface for monitoring and data analysis. How we detect the leakage action plan. We work on a 3-step. The first step, data collection. It's very important to calculate the non-revenue water for every zone. We collect the data from the water supply and consumption tracking. And we are to step another action, step testing. The goal here is to gradually reduce search radius, and of course continue follow up for the all unit of smart unit. Now Bitola area currently have a platform specialized, as you see, and which show flow meter for every flow meter reading for every zone. And after we installed all units of the smart water solution, we chose one zone, as you see, to start working. How we detect the leakage on this zone? For example, the team chose selected valves in the network and look for any change in the water flow to the zone by 48 hours. If any significant drop in water flow, the team would move to next stage to investigate the cause of the leakage. We expected will be a technical report including define losses, define factors, type of losses, and the places of intervention. And all of them lead to lower of non-revenue water, increased financial income, and smart project in another area based on steering committee with partners, World Water Net and Palestinian Water Authority. Finally, of course, we will take the action based on the result. The action will be from the municipality and Palestinian Water Authority. For example, evaluate or replacing water meters or fixing leakage pipe, detect of illegal connection, and if it required high cost, the Palestinian Water Authority can support them against for deduction of debt on this region. Thank you, and I would like to thanks for the Aqua and the World Water Net, my manager, Mr. Case, for giving me the great opportunity to participate. Thank you again.
Thank you very much, Tuka. So I think we had a wonderful overview of activities that can be done inside WOPs. You got a little bit of insights, especially on the drinking water side, from non-revenue water to water production and so on. So yeah, if you have any questions, please, I suggest I collect questions, and we have still some time, so I hope you have still some time and are not so hungry. Please.
Thank you. My question is to Tuka. Thank you for the presentation. This is Hassan Ibrahim from Oxfam, Iraq. So my question is, when you divided the zone, the area to the zones, there was a connection between those, and you removed those connections, or how did it work?
No. Okay. I will speak in Arabic. You are from Iraq, yes? Okay. احنا قسمنا المنطقة ل4 زون، تمام؟ طبعا هي منطقة صغيرة بطولها. هلا كل بداية زون احنا ركبنا سمارت ووتر ميتر، تمام؟ أو تلقائيا هذا السمارت ووتر ميتر for every zone بنقل المعلومات لبلاتفورم بتظهر أمامنا، والقراءة بتظهر على الويب بلاتفورم. شكرا.
Okay, thank you. Please.
لا كل واحدة لحال، كل زون لحال، بتحسب النون ريفينيو ووتر لكل زون لحال. يعني سمارت ووتر ميتر مركبة على كل زون وبتحسب النون ريفينيو ووتر في كل زون.
يعطيك العافية مهندس غسان.
please.
اوكي. انا بدي احكي بالعربي عشان بس ما تقاطعنيش. لانه عندي سؤالين سريعات. موضوع الانثراسايت ازالته بده دراسه وعنايه فائقه، لانه موضوع الانثراسايت له علاقه بالباك ووش تايم، له علاقه بحمايه الساند فلترز، ويمكن يكون في عندنا مشكله بالمي. تمام. فالتجربة يعني بدها تكون مدروسة صح، انك تشيل انثراسايت تحط محله ساند فلتر، وبيحمي الساند، هو بيحمي الميديا، بيحمي ميديا الساند اللي تحتيه، وبعطي سيرفيس اريا عالية الانثراسايت. النقطة الثانية الاو ار بي وين ركبته وليش ما ركبت مكانه كلورين انالايزر؟ وشكرا.
بالنسبة للموضوع الأول إحنا ما أزلنا الأنثراسايت، إحنا خفضنا من سماكته، بس هاي هي يعني هذا كان التعديل على فلترين وخاضعات الآن للمراقبة. بالنسبة للموضوع الأو ار بي إحنا يعني الأو ار بي مؤشر لكم بتكون جرعة الكلورين دايوكسيد، عرفت كيف؟ فهي يعني انديكيشن بتعطيك إنه الجرعة مناسبة أو غير مناسبة، سواء كان كلورين دايوكسيد، سواء كان كلورين، سواء كان يعني أي مادة مؤكسدة بتضيفها على المي بتفحص الاو ار بي. اذا كان الاو ار بي 700 ملي فولت معناه انه الجرعه كافيه.
I can add.
Yes.
I would like to add something to the anthracite. The anthracite on top of the sand is a coarse material. And it is for safety reasons if flocculation and sedimentation are not working well and a lot of sludge are going to the filters. Then the anthracite can take this sludge. But after optimizing flocculation sedimentation, we don't need so much anthracite. So we can increase the sand bed to get better drinking water quality. That's the idea behind it.
بالنسبه لموضوع الاو ار بي، احنا بنعمل جار تيست على الاو ار بي، ما ركبنا يعني اونلاين او ار بي ميتر، احنا بنعمل جار تيست في المختبر عشان نحدد الجرعه المناسبه من الكلورين دايوكسيد. تمام. شكرا.
Yeah, please introduce yourself.
اوكي، مش مشكله. شكرا كثير على المؤتمر. اسمي مصطفى السويسي، مهندس مياه وبيئه. سؤالين سريعات ومختصرات. السؤال الأول أستاذ غسان، خطر يعني للمعرفة، ليش أجلتوا أو أخرتوا البوليمر عن الكواجيليشن في FeSL3 هيك؟ هل هو تداخل المركب العضو ممكن يتفاعل هيك؟ الأدوية نفس الشيء، أحيانا إذا واحد أخذ دوايين ممكن يتفاعلوا، يعني ممكن يكون زيادة فعالية. هذا هو يعني على المعرفة، جديد علي. والسؤال الثاني للمهندس التقى، هو سؤال خطر على بالي وسريع جدا. ما هو المزود او موارد المياه اللي بيشربوا منها الفلسطينيين؟ هل هي مياه جوفيه؟ هل عندكم سدود؟ يعني انا ما بعرف، عندي خبره قليله بالجغرافيا، بس حب اعرف. شكرا جزيلا للمؤتمر.
طيب بالنسبه لسؤالك احنا ليش اخرنا، كان التاخير بناء على تجربه تمت في المختبر اللي هو الجار تيست اللي احنا عملناه، والشغله الثانيه حتى يعني رفع لكفاءه عمليه الفلوكيوليشن. تمام. فاحنا يعني بنعطي فرصه اول شيء تتكون الفلوك، بعد ذلك بتم عمليه اللي هي اضافه الكاتيونيك بوليمر، وهذا الوقت يعني له دور يعني مهم في عمليه الكاجوليشن والفلوكيوليشن. هذا اللي احنا يعني اشتغلنا عليه ووصلنا لنتائج في المختبر على اللاب سكيل، بعدين طبقناها في المحطه وكانت النتائج يعني ناجحه 100%. تمام. شكرا.
And second, yeah, please.
بالنسبة لفلسطين مصادر المياه في من المياه الجوفية، وفي كمان من تحلية مياه البحر بالنسبة لقطاع غزة. هو المصدر الأساسي هو المياه الجوفية، بس طبعا الفلسطينيين فيش لهم أي تحكم في إنهم يسحبوا أو يحفروا مياه جوفية، فالمصدر المياه هو من إسرائيل المزود لا السلطة الفلسطينية، والسلطة الفلسطينية بتوزعها على البلديات. هاي يعني بالمختصر.
Thank you very much. Any more questions? Maybe Engineer Malak, maybe do you want to add to what the Palestinians are doing? So in terms of non-revenue water, what you are doing at Miyahuna, or quick, just very shortly? Because I guess non-revenue water is the topic everywhere.
Yeah, it's a topic everywhere, and Engineer Abdullah is there, so like just quick things. In the presence of Engineer Abdullah, no one can talk about non-revenue water, but allow me, Engineer Abdullah. So in Miyahuna, we have a goal to reduce the non-revenue water 2% annually, and we're trying different smart system in order to monitor and control the systems. In the first day, there were a presentation about a smart utility transformation. And in this project, we will use the artificial intelligence as well in controlling the primary system and to do the active leak detection. So like it's a hot topic to be discussed, and like it's another part of partnership. Yeah. So thank you, Claudia, for your question.
Any comments to that? Yeah, please.
First of all, I would like to thank everyone for the very interesting topic to talk about, the non-revenue for water. Actually, in Jordan and Miyahuna in Jordan, our situation is very unique because we don't have a continuous supply. Even we don't have intermittent supply like some of the countries that they have water every day in a certain time. But in Jordan, we have it once a week, day or two. So the shortage of water make a lot of problem to the network, cause a lot of problem of measurements, leak detection, pressure management, supply equity. It's very hard topic. It's very hard situation. What we are doing all what we have. The traditional way, the technology. Nowadays, we are trying to use the intelligence to control our network, starting from supply, from the primary, then as Engineer Malak mentioned, to go beyond to control inside the pressure, to detect leak, to measure, to have good measurements, accurate measurements. So it's very hard situation in Jordan. The problem, as I mentioned, it is a unique situation. That's why I was hoping from the partnership with Hamburg to have it as a case study, to focus on the intermittent supply and its impact on the non-revenue for water, which is the most important KPIs for any utility working in water. Please focus on the intermittent supply case. There's no literatures about it.
Yeah.
There's no, sometimes I hear from the expert, your situation is dead.
Yeah. No,
that's why
we're
always looking for a solution, not a step by step. We need a full solution. And we have a lot of work, we have a lot of results. We succeed in some and fail in others.
Yeah, thank you. Yeah, I mean, we are, of course, aiming at a longer-term partnership, and so we started with this topic that were described, but we look also for further topics. So when we have one, more or less solved, then we can look for new topics. And I think non-revenue water can be one part, and of course, but we have not all the knowledge, but we serve you as a sparring partner. We have also some experience from other countries where we have also intermittent water supply. So we have also some experts who can serve as sparring partner for you. Yeah, thank you. So if there are not any more questions, so I want to introduce one person from GIVOPA, Emrah. GIVOPA is the global alliance who is supporting very much the Water Operators Partnership worldwide, and I'm happy that you are here. And I'm pleased to invite you to give a few summarizing words. So I don't know how much time you have and how much, but you can be brief maybe. And please, Emrah.
Thanks, Claudia. So Claudia asked me to actually summarize the discussion, which is not the easiest part. So I'll try my best. So basically, we look at a little bit the WOP concepts, what is this really, what motivation comes from the mentor side, also mentee side. We discuss a little bit about those issues. And we also sort of like look at the concept of the WOPs from the peer-to-peer learning, partnership between public utilities and being focused on trust building and making sure there's a eye-to-eye level sort of partnership. So it's really focused, bringing expertise of partner and sharing information and knowledge. And we then had like two basically the case studies. I'm not going to details of the Christoph sort of like a detailed engineering model on water optimization, but what comes out from that sort of like really discussion is there is this knowledge that is being tested and actually and used and there probably used a lot of resources to actually test this knowledge, to actually verify the results. And these results are actually being used by the Miyahuna, and as a result of this partnership, they actually managed to have a better water quality by reducing at least 100 tons of chloride per month, which equivalents of 24,000 JD per month, sort of like saving cost, if I'm not wrong, so please correct me. So this is one practical actually results of the partnership, how a knowledge that is being produced elsewhere can be actually available to someone elsewhere, so that translates actually better quality of water, first of all for everyone, but also there is a financial implication for utilities. And then the same goes for the partnership between World WaterNet and the Palestinian, the utilities. So by introducing actually smart sort of solutions to detect the leakages and reduce the sort of like the non-revenue water. So, I mean, the conclusion is there is the knowledge produced elsewhere. We don't need to reinvent the wheel. We just need to actually find those partners and bring them together and learn from one another. Thank you.
Thank you very much, Emrah. So are there any more questions? So otherwise, we can also continue the discussion. I think the experts are still here around, so during lunchtime or so. I just wonder, Emrah, you have not mentioned your congress that you're organizing. So maybe I can mention it shortly, because it's a congress that will take place in Germany this year in end of May. So there's still time to register. And it is especially a global congress about WOPs, so about water operator partnerships, exchanging each other, and I think you expect also lots of international participants, and it's also supposed to be a hybrid congress. So it's end of May, and we also, quite a number of persons from our WOPs, our international partners from Hamburg Wasser will be there, so we are happy to meet you also in Bonn, if there's time and if you're available. Please, and now I wish you a very nice last part of this Water Week. Thank you very much for coming. Bye.